Welcome to Linked Data Engineering. This is lecture number 2 about RDF and RDFS. In this section of the lecture we want to talk about RDF reification. So we are still among the same level in the semantic web layer cake. We are on the layer of the resource description framework and we are talking about further possibilities and refinement of the RDF syntax. So what we want to discuss now is to make statements about statements, simply like this very nice example of Sherlock Holmes who says, "My dear Watson, I suppose that it was the gardener who has killed the butler." So how to represent a fact like that in RDF? RDF luckily provides a way of interleaving statements, so to make statements about statements. We have the example here, Sherlock Holmes supposes that the gardener has killed the butler. So this sentence consists of two parts. So the first part, the last one, is expressed as a simple RDF fact. So we have here the gardener has killed the butler, which you see here, part 1, the gardener has killed the butler. But the second part, Sherlock Holmes supposes this statement, then this is more difficult to express in RDF. So we have here that Sherlock Holmes supposes something, and this something should be part 1. But we cannot simply write part 1 instead of the question marks here. How is this solved in RDF? And it's resolved with a construct which is called RDF statement. What we can do is we can define something to be a statement to consist of subject predicate object or subject property object. And then if we have defined this and given this thing a URI, we can make another statement about this statement. And this then is called reification. So RDF statement is the solution. So this in the end defines a class consisting of subject, predicate and object. So note here we are usually referring to properties and not to predicates. But the keyword in RDF here is used, it's predicate, simply because there exists also a keyword which is called RDF property, and this is required for the definition of RDF properties in RDFS. So therefore here in this statement it's referred to as predicate. So this is also the usual name for this thing in a statement in natural language or in linguistics. So a statement consists of RDF subject, RDF predicate and RDF object. As you see here, the gardener would be our subject, has killed would be our RDF predicate, and the butler would be the RDF object. And the entire thing then is the RDF statement. Let's have a look at on how our entire construct then would be expressed in the RDF graph representation. So Sherlock Holmes supposes that the gardener has killed the butler. So first we have Sherlock Holmes. Again, we take this from DBpedia. And we say Sherlock Holmes supposes a statement which we call statement of Sherlock Holmes. And the statement itself that you see here is connected to an RDF subject, which is the gardener. It's connected to an RDF predicate, which is has killed, and connected to an RDF object, which is the butler. In this way, you are able to make statements about statements. And of course, you can continue that to make statements about statements and so on and so on and so on, simply because the RDF statement we are talking about, so this one, statement of Sherlock Holmes, is of type statement, and of course it has been assigned a URI, therefore it can be referenced from anywhere. So let's have a look at the turtle representation of that. It's quite easy. You see here, first we say Sherlock Holmes supposes a statement. And we call this statement, or we give this statement, the URI statement of Sherlock. And then in the next triple we define the statement of Sherlock. So we say here statement of Sherlock is an RDF statement, so is of RDF type, RDF statement. And then we define the RDF subject, which is the gardener. We define the predicate, which is has killed, and we define the butler as the object. As you see here, it's quite as easy as that. With that, you can make statements about statements. So, for what do I use these things? What is it good for? What's the use of reification? First thing, of course, sometimes for some facts you have some different, or let's say contradicting facts about the same subject coming from several distinct sources. And you have no idea which one is correct, which is not correct. So therefore, one possibility to use reification is to use it as a means of expressing data provenance. Who has made a specific assumption? Who has stated this fact? What is the source? And you can describe this provenance by reification. If you know where a statement comes from, then of course you can connect this statement also with statements about reliability and trust, which is quite important. So in general, you can define metadata about statements with the help of reification. But you should be careful. Reification is a little bit tricky if you use it really in a semantic web or linked data setting, simply because it changes somehow the roles. So the relations or the properties become instances or classes. So you might end up with type conflicts in strictly typed languages. And another thing is, of course, if you use your statement, then, for example, also a subject or object in a statement, and you use the same thing and you define a cycle, you will end up in an infinite recursion, which is also a bad thing, and you won't, of course, you don't want to do that. So be careful if you're using reification, but keep in mind it's interesting and important to express provenance. But there are more means to express data provenance and metadata about data in the semantic web step. This is only one of the many possibilities. So we have learned now a lot of RDF possibilities. What we do not know right now is how to build up new classes, how to define new properties. We have used, of course, lots of classes and properties here, but we have only given them by name. We want to define them. And how to do that? We will see that in the next chapter when we are talking about model building with RDF schema.